Today I'm going to show you or explain you about big data and data science. Big data and the data science, most of the time misuse of the words. Let me show you some what makes it different and what makes it's or what they use commonly. So in order to define, let's start from data insights. What's data insights and the steps for data insights? So through this, what are the importance or necessary of data science and the big data? They are an emerging technology, especially by fourth generation industrial revolution. So what's data insight? Let's start from this. Data insights is here is the fundamental of successful business today. From improving customer experience to optimize operations, it enables organizations to make well-informed, data-driven decisions. But raw data is useless until it is transformed into insights. So data insights are the comprehensive understanding that come from information analysis on a specific topic for a persons or organizations, and organizations are able to make better judgment thanks to this in-depth insight than they would other. You can get a clear picture of what is going on with the help of data insight. So given this, there are some misuse of word by several analytics vendors. Let's first establish what an insight is and what is not. So insights, one of the very important is data. Data is a raw fact and figures that are not processed and prepared. Our data is usually stored in a database and a spreadsheet. It is qualitative and quantitative. Information is data that is aggregated, provides more context, and organized into comprehensive formats or into understandable. The third one, insight. Insight are the obtained after analyzing information and drawing conclusions. So obtained after analyzing information and drawing conclusion is. So what are the steps for data insight? So to generate useful data insight, there are some steps we need to go through, but it all starts with strategic questions. What's the purpose of the activity? Knowing your end goal helps to establish a clear understanding what sort of result is needed. Are you doing it to uncover trends or effects? Is it for product development or sales enablers? Once there are defined outcome, then you should build roadmap not only for turning data into insight, but also for presenting and using the final result of reaching and specific goals. At this point, you will be able to know which kind of data is essential for your analysis and insights extraction. So gathering, clean up and store data. No matter what kind of analytics you are interested in, gathering relevant and reliable data is the first step. Analytics will not help you much if your data is not accurate, complete, and relevant. Data serves as the fundamental building component for all of your ensuring insight, improvement, and breakthroughs. So let's see some elements under this gathering, cleaning, and store data. Compile all the raw data. Information come in different formats. Your data can come from any kind of structured or unstructured source. The first step is to compile all the data that you have, include business data, scientific data, metrics, and performance data, and data from social media platforms. The second one is reformat and pre-processing data. The data you have just compiled is not meaningful yet or even ready for processing. In this step, you need to reform the data in a way that it becomes suitable for machine learning processing. For this, you would be required to perform decomposing, filtering, or normalizations on your data. The third one is clean up to make sense of data. Even after pre-processing, data is still bound to have some gap and imperfection. It may be inconsistent, dirty, or missing a few important values. You need to manually scourge through all the data value to find the veracity, rectify any inconsistency. This step requires a lot of time and effort to ensure it is completely clean for the actual analysis phases. When you have all data you should clean it and ensure it is free of irrelevant and inaccurate informations in data science. So understanding data, high quality data has to be valid, accurate, complete, consistent, and uniform. This is very important to ensure, or as useful or good as underlying data you can cite based on this quality that has to be valid, accurate, complete, consistent, and uniform. An essential part of this step, deciding technology or digital solution for data gathering, processing, and storing. Data insight must be accessible at any time. Selecting where to store your data depends on the combinations factors including volume and combination factor including volume and speed, reliability, and maintenance. So these are the first. The second one is reporting. After your organization has collected this data, these raw materials usually need to be cleaned, converted, combined, organized before it is truly useful, accessible through different vehicles such as schedule report, scorecard, dashboard, business reporting, transforming data into information that can be used to monitor how different parts of your organizations are performing. So the reporting. The third one is analysis. While reporting might be used to stop potential problem or opportunity, it will rarely initiate any action on its own. A deeper exploration of the report and the underlying data is needed to convert information into meaningful insight, which can be used to better understand improve business performance. The analysis is not just about mining of data for insight, but also recommending options to address a problem or size of opportunity. The potential impact should be monetized so decision makers can weigh the various opportunity costs. One of the biggest problem in analytics is too many organizations confuse reporting with analysis and fail to move beyond just providing informations. There are various techniques you can use here, from clustering to semantic analysis. What you end up with are data category, segment, and a group based on the common property and features. You can stop at this step if the results are enough to address the purpose of your data analysis. By this time, for instance, you can already get insight and track your performance. However, if you need more in-depth prediction and insight about the future trend, then feel free to proceed to the next. The next one is decision. Before insight, it can be translated into action. A decision makers or a group of decision makers typically need to decide whether or not to act on insight or recommendation. No resource will be assigned or no change will occur until decision is made. So to decide whether or not to act on particular insight or recommendation. A decision may require additional data for further analysis before an executive feels comfortable with moving forward. The final decision may not align with the analysis recommendations, or the execution plan may be altered. Example, project scope increased or decreased. This is all about decision. So, before insight can be translated into action, a decision maker group of decision makers typically need to decide whether or not act. Thus, there is action. After a decision has been made, the next step is to plan an appropriate course of action and execute on it, taking an action including testing a different approach before setting on the best one. Not every action will achieve its expected return. However, data-driven organization will learn from both this failure and success so that it is constantly refining and improving its approach over time. It And you should not only measure the impact of your site by looking process optimization and the business enhancement, but also provide room to relevant of the evaluate for the continuous improvements. The next one is, this is all about a step for data insights. We have seen all about 5 steps we have to use. Now let's move to data science. Data science is a field of study that combines domain expertise, programming skill, and the knowledge of mathematics, statistics to extract meaningful insight from data. It is a multidisciplinary blend of data inference, algorithm development, and technology in order to solve analytical complex problems. The other is, what is the aim of data science? So now we have seen data science especially to extract meaningful insight from data. So how we can do using different programming skill, using different knowledge of mathematics. So we can do this. The next one is aim of data science. Building methods for driving business focused insight from data is the aim of data science. This is called for an awareness of the value and the information flow within an organization, as well as the capacity to apply this awareness to recognize commercial opportunities. Although it could involve one-off project, data science team often look for important data sets that can be transferred into data pipelines that apply dependable tools and solutions. Example include tools used to improve the positioning of wind turbines in wind farm or credit card fraud monitoring service used by banks. The goal of the data scientist is to investigate, classify, and analyze massive amount of data from diverse sources in order to make use of them and draw conclusions that will help to improve business operations or provide decision support. Examples include predictive maintenance of machines, marketing and sales, with other-based sales forecasting being one example. Data mining, data exploration, statistical machine learning, search algorithm, regressions, data visualizations. With all these tools like Moodle, Quark, and others are pillars on which data scientists most frequently relies. Processing of business or public data, which was previously challenging the use of using conventional structural method, is being revolutionized by data science. Semi-structured data analysis is now possible thanks to the parallel between the database explosion, expansion, the introduction of new technology around the machine learning, artificial intelligence, and the big data. So now we have seen data science and the aim of data science. So next, what is big data? Why we need big data? What makes different from data science? How data science, big data, and also the aim of data science that's called from. This is all. So what's big data? Big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. So big data term is a collection of data sets too large and complex that become difficult to process using on-hand database management, that means using relational database management system. The other is, what is big data characteristics? 5 characteristics define big data: volume, velocity, variety, veracity, and value. Together, these characteristics define big data they have created and the need for new classic capability to augment the way things are done today to provide a better line of sight and control over our existing knowledge domains and the ability to act on them. Number one, volume. Volume describes the enormous volume of data generated every second by social media, mobile device, vehicles, credit card, machine-to-machine sensors, photos, movies, and other sources. The amount of data being stored nowadays is growing rapidly. About 800,000 petabytes of data were achieved globally in the year of 2000. Of course, a lot of the data that is produced nowadays is even evaluated so that the presence and other issues that must be taken into account. By 2020, this amount is anticipated to reach 35 zettabytes. Facebook creates 10 terabyte data each day, while some business product terabyte of data every hour, every day of the year. Twitter alone generates more than 7 terabytes of data per day. Individual businesses now often have storage clustering carrying petabytes of data. When you stop and think about it, it is little wonder we are drawing data. We store everything: environmental data, financial data, medical data, surveillance data, and the list goes and on. For example, taking your smartphone out of your house generates an event when your commuter train door opens. That is even check in for a plan, badge into work, buy a song on iTunes, change the TV channels, take an electronic tour. Every one of these actions generates data. Okay, you get the point. There is more data than ever before, and all you have to do look the terabyte penetration rate of personal home computers as a telltale sign. We used to keep a list of all data warehouse. We now that's surplus several almost this year ago sufficient to say things have changed when it comes to volume as implied by the term big data. Organizations are facing massive volume of data. Organizations that don't know how to manage this data are overwhelmed by it, but the opportunity exists. With the right technology platform to analyze almost all of this data are to least moved by identifying the data that's useful to you to gain better understanding of your business, your customer, and the marketplace. This leads to the current conundrum facing today business across all industries. This is all about volume. So volume is one of the major or the first characteristics of big data. The other is variety of data. The second one is varieties of data. The volume associated with the big data phenomena brings along a new challenge for data centers. Trying to deal with it is a variety with explosion of sensor and the smart device as well as social collaborations. Technology, data, and enterprise has become complex because it includes not only traditional relational data but also raw semi-structured and structured data from web page, weblog file, including clickstream data, search index, social media, forums, email, document, sensor data from active and passive system. What more traditional system can struggle to store and perform required analytics to gain understanding of the content of this long because much of the information being generated does not lead itself to traditional database technologies. In my experience, although some companies are moving down the path by and the large most are just beginning to understand the opportunities of big data. Quite simply, variety represents all types of data, a fundamental shift in analysis requirement from the traditional structured data to include raw, semi-structured, and unstructured data as part of the decision-making and insight process. Traditional analytics platform cannot handle variety. However, an organization's success will rely on its ability to draw insight from the various kinds of data available to it, which include both traditional and non-traditional. When we look back at our database career, sometimes it is humbling to see that we spend more of our time on just 20% of data, the relational kind that is neat formatted and feed over nicely into a strict schema. But the truth of the matter is 80% of the world data and more of this data is responsible for setting new velocity and volume records is unstructured, semi-structured at best. If you look at Twitter's feed, you will see structure in its JSON format, but the actual text is not structured. And understanding that can be rewarding. Video and the picture image are not easily or efficiently stored in the relational database. Certain event information can dynamically change, such as weather pattern, which is not well suited for strict schema, and more. To capitalize on the big data opportunity, enterprises must be able to analyze all types of data, both relational and non-relational, text, sensor data, audio, video, transactional, and more. So the variety or different types, structured, semi-structured, unstructured, are also very important, especially in decision making. Nowadays, more than 80% of the data in the world is unstructured and semi-structured. Good. The next one is the velocity. What's velocity of data? Velocity plays a major role compared to others. There is no point in investigating so much to end up waiting for the data. So the major aspect of big data is to provide data and demand that is faster place. Just as the sheer volume and the variety of data we collect and the store has changed, so too has the velocity at which it is generated and needs to be handled. A conventional understanding of velocity typically considers how quickly the data is arriving and stored and its associated rate for retrievals. While managing all of that quickly is good, and the volume of data that we are looking at are a consequence of how quickly the data arrives. To accommodate velocity, a new way of thinking about problem must start at the anticipation point of the data, rather than confining the idea of velocity to the growth rate associated with your data repositories. We suggest you apply this definition to data in motions, the speed at which data it is flowing. So this is the velocity, data in motions, the speed of data that measures to store as well as to retrieve. Good. The fourth one is veracity. Veracity basically means the degree of reliability that the data has to offer. Since a major part of the data is unstructured and irrelevant, big data needs to find an alternative way to filter them or translate them out, as the data is crucial in business developments. Veracity, how much we can depend on that data. The last one, value. Value is a major issue we need to concentrate on. It is not just the amount of data that we store or process. It is actually the amount of valuable, reliable, and trustworthy data that needs to be stored, processed, analyzed to find insights. This is all about big data characteristics. Now let's move to what are especially tools used in big data and data science. Number one is Hadoop. Hadoop data ingestion is the beginning of your data pipeline in data lake. It means taking data from various silo database and the files and putting it into Hadoop. Hadoop could be described as an open source program to handle big data, utilizing the MapReduce model. Hadoop distributes data across this node, which are a network of connected computers. So Hadoop is an open source program to handle big data by utilizing the MapReduce model. MapReduce is a way data in a big data is processed, and the Hadoop is distributed the file across the data. This data is shared across the system and is enabled to handle and process a very large amount of data at the same time. This collection of network nodes is called the Hadoop cluster. So data is in a cluster in different nodes, in different areas. Hadoop leverage the power and the capability of this distributed file system, which can handle reading and writing large files from log files, database, raw files, and other forms of streaming data for processing using injection tools such as Apache Flum, Stream, and so on. The HIDF or Hadoop distribution file system ensures the ingested data are divided into smaller subunits and distributed across the system in the cluster. Where writing the HDFS data are sliced and replicated across the server in Hadoop cluster. Ingest files straightforward, optimize of import all of file into Hadoop or data like loading over server than Hadoop command line to ingest data for loading file to loading server from variety of sources. There is ample technology available. Keep using what you are and just use Hadoop command line to load the data into Hadoop, Azure Data Lake, S3 or GCS, Google Cloud Storage, and so forth. So let us see some very important elements, that are especially used for ingestions data from different or various sources into Hadoop. There are a lot of structures because the Hadoop is one of the tools especially designed for big data. So the big data is the information that can store multi. So there are different variety, different things of. So how a stream is a piece of software having the ability to continually transport real-time data from a variety of sources into Hadoop, Kafka, relational, or NoSQL database, both locally and as stream is an intrusive, quickly deployable streaming integration solution is provided to you by the core team behind Golden Gate Software so that your Hadoop solution may serve a wide range of operational use cases. With the capability streaming data integration for Hadoop enables smart data architectures that support use case-driven analytics in enterprise data lakes. Ingestion large volume of real-time data for database long file measure system and sensors. Number 1. Collect change data non-intrusively from enterprise data such as Oracle, SQL servers, MySQL, HB, and so forth. Delivery data in milliseconds to Hadoop, HBase, Hive, Core, Kafka, Haskell, Mongo, relational database cloud environment, and other targets. Support mission critical environment with end-to-end security, reliable, HA, and scalable. These are one of the capabilities of Stream. The other is the benefits. The benefit of Stream also various. Use low latency data for operational use case, accelerate time to insight with continuous flow of transformation data, ensure scalable security, reliable for business critical solutions, achieve fast time to market with wizard based on user interface and SQL based languages. These are the benefits of stream ingestion. The other is the key features. Enterprise grade and fast to deploy streaming integrations for hard real-time integrations of structured and unstructured data, flight filtering, aggregate transformation and enrichment, continuous ingestions and processing at scale integration with existing technology open source solutions. So Stream enables business to get the maximum value for high velocity, high volume data by delivering it to Hadoop environments in real time in the right format for operational use cases. Also, Stream ingests real-time data from transactions database, log files, message queues, sensors for untransferred database, including Oracle's Microsoft SQL Server, MySQL, HP, and so forth. Stream offers also non-intrusive change data captures features to ensure real-time integrate minimal impact source system and optimize the network slightly by moving all the change data. Okay, this is all about, in short, we want to see. Thank you. My name is Balai. Next, we'll try to make something.